Good morning, students. So, in today's class, we are going to discuss about the new chapter, the very important chapter, that is P block element. P block element. So, students, this chapter carries total 10 marks. Okay, in that 1 marks, 1 question, 3 marks, 3 question. Okay, so this totally carries 10 marks. 1 marks, 1 question. That is question number 5. Okay, 1, 2. Question number 6 it is. Okay, next 3 marks, 3 questions. That is question number 20, 21, 22. 3. 20, 21, 22. Total 10 marks it carries. 1 marks 1 question, 3 marks 3 questions. Okay. So students here, this P block elements means first initially I will say the what are P block elements? The last electron of the element, if it enters into the P subshell like P1, P2, P3, P4, P5 and P6. Okay, P1 to 6. If the last electron of the element enters into P subshell, that is called as, those elements are called as P block elements. Okay, so in the periodic table, the P block elements are present at extreme right of the periodic table. Extreme right. Okay, that P block element completes the periodic table. So in that, the group in the periodic table 13 to 18. 13 to 18 group are called as P block elements. So students, the general electronic configuration of P block element is Ns2, Np, 1 to 6. This is the general electronic configuration. So in the before, the first year, we already studied group 13 that is boron family and group 14 that is carbon family. In the second PUC, you are going to study the nitrogen that is group 15, 16 and 17, 18. So this one is nitrogen family, oxygen family, fluorine family and the noble gases. Okay, pictogens, chalcogens, halogens as well as noble gases. These 4 groups we are going to study in this P block element. This chapter is very important. Understood? So students here, the general electronic configuration of this only S block element is Ns2, Np3. So this one is Ns2, Np4. This one is Ns2, Np5. This one is Ns2, Np6. So these are called as pictogens. These are chalcogens. These are halogens. And these are noble or rare or inert gases. Noble gases or rare gases or inert gases. You know that why they are called so. Noble means because they are very precious. Rare means their occurrence is very less. Inert means they have a stable configuration. That's why they are very inactive. They are very passive to the incoming species. They are very strong. They are stable. So they cannot easily react with any other element to form a different products. Okay. That's why students, always the noble gases are almost monoatomic. Monoatomic means they exist alone. Helium, neon, argon, krypton, xenon. We can write them as like this only. Helium, it is alone. But if you want to check hydrogen, it is H2. Oxygen, O2. These are all diatomic. Okay. So because of the stable configuration, they won't form any bond with any other elements easily until extra energy Until we apply extra energy, they won't form any bonds. Okay? So in that, students, we will discuss one by one. So we will start with our group 15 group elements. So listen, how we are going to study initially. Any other group is that group periodic properties, chemical properties, periodic properties, physical properties, chemical properties, and their compounds. Okay, this is the way. Okay, so 15th group element, 15th group elements, that is nitrogen family. What are the elements present here is nitrogen, phosphorus, arsenic, antimony, bismuth, Okay, last one is the radioactive element. We won't consider that. So nitrogen symbol is N, this is P, this is AS, this one is antimony is SB because it is stibnum. Antimony, the name is stibnum. So bismuth is Bi. Okay. So these two are students non-metals. These two are non-metals. These two are metallites. And this one is metal. From these, what you are going to observe, and their configuration I write. So this configuration is helium 2s2 2p3. Next, neon 3s2 3p3. Next, argon 4s2 4p3. Krypton 5s2 5p3. Xenon 6s2 6p3. Understood? So here students, listen, 2s, 2p, 3s, 3p, 4s, 5s, 6s, like that is there. So if you want to consider the periodic properties, These periodic properties, first one is electronic configuration. First one is electronic configuration. Okay. So the electronic configuration of these is NS2, NP3, main easily 2s2, 2p3, 3s2, 3p3, 4s2, 5s2, 6s2, 7s2. As well as to NP3. Hence, this is the valence electronic configuration. Next, second one is atomic size. Okay, so what happens to the atomic size here? Here are two subshells, 3, 4, 5, 6. Means number of the shells goes on increases if it is the nucleus. 1s, 2s, 3s, 4s, 5s, like this. So the number of shells goes on increases means the size increases. So atomic size increases from nitrogen to bismuth. Atomic size increases from nitrogen to bismuth. Next, third one is electronegativity. You know students, to non-metals, electronegativity is more, to metals, electronegativity is less. So along the group, metallic character increases, non-metal, metallite, metal. Along the group, metallic character increases, means this one is highly electronegative, this one is less electronegative. So that means electronegativity decreases from nitrogen to bismuth. These are the trends you have to remember. Okay, next last one, that is ionization energy. Ionization energy. You know that if size increases means remaining all the periodic properties decreases. So ionization energy also decreases from nitrogen to bismuth. These are the types. Electronic configuration NS2 atomic size increases from nitrogen to bismuth. Electronegativity decreases from nitrogen to bismuth. Ionization energy decreases from nitrogen to bismuth. Electron gain enthalpy also decreases from nitrogen to bismuth. Okay, so these are all periodic properties. So if we come to physical properties, if we compare the physical properties, these are right, periodic properties over. Next one is physical properties. So students, in the physical properties, you know, boiling point is there, melting point is there, their state is there. Okay. So here, the first physical property is nitrogen is gas. Nitrogen is diatomic gas. All are remaining are solids. Okay, except nitrogen, phosphorus, arsenic, antimony, bismuth, all are solids. And right here, this is a gas. All these four are solids. This one is gas. That's what I wrote here. Okay, so the next one is nitrogen and phosphorus are metals. Arsenic and antimony are metallites. Okay, and last one, bismuth is metal. Bismuth is metal. That is the physical property. Okay, next one is the boiling point increases from top to bottom. Means along the route, the boiling point increases because you know non-metals have less boiling point, metals have high boiling point. Okay, so that's why the boiling point increases from top to bottom, from nitrogen to increases from nitrogen to bismuth. Nitrogen to bismuth. Okay, so these are all physical properties. Next one is there, that is chemical properties. This is what general properties I am telling, not particularly chemical properties. Okay, so in these chemical properties, the first one is reaction with hydrogen. Okay, reaction with hydrogen means they form hydrides. Understood? And right here, in this reaction with hydrates, they form the compounds EH3 type. EH3 type. And right here, that is NH3, PH3, ASH3, SBH3, and BiH3. So they form the compounds with hydrogen likes with compounds like EH3, NH3, PH3, ASH3, SPH3, and BH. So students, this is acidic in nature. This is basic in nature. Basicity decreases from nitrogen to bismuth. You have to remember that. What is the order of the basicity? The stability of hydrides decreases from this to stability. This one is highly stable. This is the decreasing order of stability. Means this one is highly stable, this one is less stable. Why? Because listen students, these can exhibit the oxidation state -3, +3 as well as +5. These as the capacity, and right here this point, these are the capacity to exhibit -3, +3 and +5 oxidation state. If they react with hydrogen, they exist in +3 oxidation state. These are stabilized like this. Understand? And remember students, the stability of +3 oxidation state decreases from nitrogen to bismuth. Means these are nitrogen is highly stable in +3 oxidation state. Next, stability of +5 oxidation state increases from nitrogen to bismuth. Means nitrogen is unstable, less stable in +5 oxidation state, highly stable in +3 oxidation state. This bismuth less stable in +3 oxidation state, highly stable in +5 oxidation state. And last one is stability of -3 oxidation state. Oxidation state decreases from nitrogen to bismuth. -3 also decreases, +3 also decreases. You know, here I wrote stability. NH3 is greater than PH3, greater than ASH3. That means what? The stability of -3 oxidation state decreases from nitrogen to bismuth. So this is what reaction with hydrogen, they form EH3 type compounds, and reaction with oxygen, they form EO3, E2O3 and E2O5 type compounds. Trioxides as well as pentoxides, P2O5, N2O5, N2O3, Bi2O3, like that. Trioxides as well as pentoxides with +3 oxidation state as well as +5 oxidation state. Both the oxides they will form, but the students, the stability of those oxides is, okay, if I compare this one, N2O3, next P2O3, next ASO3, next SbO3, next Bi2O3. So students, this is the stability we consider. As I told you, the +3 decreases from nitrogen to bismuth. This is highly stable. This is the truth. And remember, these two are acidic in nature. These two are acidic in nature, and these two are amphoteric in nature. Very important. And this one is basic in nature. Remember why? Listen, if the oxides of non-metals, as I told you, the halides are there or oxides are there. If the halides of non-metals are there, they are covalent. If the oxides of non-metals are there, they are acidic. Next, oxides of metallites. They are in between metals as well as non-metals. That means, listen, oxides of metals is what? Basic. Halides of metal is what? Ionic. NaCl is there. Metal halide. That is ionic. HCl is there. Non-metal halide. Okay, that is covalent. In between that, I am telling metalloids between non-metal and metal. So this is acidic, this is basic, means obviously these are amphoteric. Understand? So these are very, very important for one. Only this much enough. If you know these things, students, not only in this, remember, in all the, whether if I consider this is nitrogen family, of course. If I consider oxygen family, in the place of this oxygen, sulfur, selenium, tellurium, polonium will come. So this trend follows same, this trend follows same, this trend also follows same. But the thing is, here the formula change. EH3 type compound is there, EH2 type compound, therefore here A plus 1 oxidation state is there, but that means SO2 type, this EO2 type compounds they will. Later I will explain. The general properties are very important. These trends are very, very important. Remember? Okay. So this much carries at least 2 to 3 marks for you. Okay, 1 mark question are answered here. So the one more important question is there in that this order they will ask. Write the decreasing order of stability of hydrates of nitrogen family, hydrates of oxygen family, hydrates of fluorine family. Okay, whatever they answer, but this is very important. Understood? So the next one is, I hope periodic properties will be physical, chemical. These are the general properties of 15th group elements. Understood? General properties of 15th group. Now we are going to study only the elements of nitrogen and phosphorus one by one. Alone the elements of nitrogen and elements of phosphorus. Remember students, another one, before I can easily say the anomalous gear, every element in the first, okay, 13th group is there, boron is there, in the 14th group first element is carbon, in the 15th group first element is nitrogen, in the 16th group first element is oxygen as well as helium or neon. So these all exhibit some of the different behavior with respect to other elements of the group. Okay, I'll explain. Okay, so the next one is anomalous. So the first element of the block element, that is 15th group, that is what? Nitrogen. So in all what I am telling is the first element is always studied as the anomalous behavior and anomalous property. So students here, I write anomalous behavior of nitrogen. Anomalous behavior of first nitrogen already. Okay. So students, 4 reasons are there for anomalous behavior. Why anomalous means different? Why it behaves differently from the respective elements of the same group. So nitrogen behaves differently from phosphorus, arsenic, antimony and bismuth. What is the reason? The first reason is smaller size. Okay. Second one is high electronegativity. High electronegativity. Next, high ionization energy. Last one, absence of d orbital. Okay, so students, if you write the electronic configuration of nitrogen, it is 1s2, 2s2, 2p3. The next is 3s0. So if you consider phosphorus, that is 1s2, 2s2, 2p6, 3s2, 3p3, but the same 3d0 is there. But in the same shell, it has d orbital. So for example, K shell means 1s, L shell means 2s, 2p, M shell means 2s, 2p, 2, 3s, 3p, 3d. This is nucleus means 1s, 2s, 3s. In the same subshell, d orbital is there. So after phosphorus, each element includes d orbital. The presence of d orbital is there. But here, after the 2s, 2p, there is no d orbital, directly 3s orbital will come. So absence of the d orbital in the shell, only K shell, L shell is there. In L shell, there is no d orbital. Understand? So that is the reason why this nitrogen behaves differently. Okay? So what are the properties that tells the hydrogen is different from other elements? So that is called as what? Anomalous property. Then I ask different students, what are anomalous behavior? Reasons for anomalous behavior and reasons for anomalous property. Property is different, behavior is different. Why is it show different property means because of these reasons. Okay. So the first one property is nitrogen forms p-pi bond, whereas other forms compounds, other forms only single bond. Single bond you may say or okay, it may be a sigma bond only. Okay, so students, while you are writing nitrogen, how you are going to write? Like this, N triple bond N. Means this nitrogen has the capacity to form p-pi bond within itself. Okay, but if you consider P4, it is like P. So of course the elements bonded with each other, but they are singly bonded. They don't have the capacity to form p-pi bond. Understood? Nitrogen forms p-pi bond, whereas other elements forms only a single bond or a sigma bond. This is the example. N2 and P4. N2 is like this, P4 is like this. All are with a single bond. Okay? So the next one is nitrogen forms oxides in all the oxidation state. All the 5 oxidation state. All the 5 oxidation state. Okay? I write an example here. N2O, this is plus 1 oxidation state. NO, plus 2 oxidation state. N2O3, plus 3 oxidation state. NO2, plus 4 oxidation state, N2O5 plus 5 oxidation state. Whereas other elements forms only plus 3 and plus 5 only E2O3 and E2O5 type oxides. Means the remaining elements only form oxides of plus 3 as well as plus 5 oxidation state, but this nitrogen forms oxides in all the 5 plus 1 plus 2 plus 3 plus 4 5 plus 5 oxidation state. Okay, next. Nitrogen has the coordination number 4, whereas other elements as 5 and 6. Nitrogen has coordination number 4, whereas other elements has 5 and 6. What is the reason for that? Listen, SR that consists of only sp orbital, 2p, sorry, 2s, 2p. This is what? Nitrogen. Okay, students. So this nitrogen has 4 orbital. The next orbital is 3s. It is an higher orbital. It requires more energy to handle extra subshell. Correct? So that's why it has 4 subshells, means it has a maximum coordination number is 4. But you consider phosphorus. Phosphorus means it is 3s, 3p, of course 3d is also there. 3s, 3p. In the same orbital, 3d also there. That means they may extend their coordination number up to 5 and 6. Understand? So nitrogen has coordination number 4, whereas other elements has 5 and 6. What is the reason for that? Due to the absence of d orbital. Listen, I am telling you. Nitrogen forms p pi bond, whereas other elements single bond. Reason is smaller size. The nitrogen forms oxides in all the 5 oxidation state, whereas other elements forms only E2O5. The electronegativity is more. Next, the nitrogen has coordination number 4, whereas other elements has 5 and 6. Why? Because the absence of the d orbital. Correct? Here there is no d orbital, here there is a d orbital. These are the reasons why they behave differently. These are the properties how they behave differently. Okay? Another one property in nitrite, because the anomalous property and anomalous behavior they last you for 2 months. Okay, so another one, students. Nitrogen cannot form NH5 compound, whereas others easily form. Whereas others easily forms EH5 compounds. Because why it didn't form NH5? Again the same reason, absence of d orbital. Okay, so these are all the properties of anomalous properties of nitrogen. Understood? This is the anomalous reason, this is the anomalous behavior. Both are very important for 2 marks. Not only nitrogen, it may be oxygen, it may be fluorine, any first element. Anomalous behavior for all is same. Smaller size, higher electronegativity, higher ionization energy, absence of d orbital. Okay? For oxygen same, for fluorine same, for carbon also same. For carbon only, instead of d orbital, we have to take p orbital. Sorry. D orbital only, that is all. In p block elements, all the elements are same. Reason for boron is also same. These four reasons. For carbon also these four reasons. For nitrogen also these four reasons. Oxygen, chlorine, helium. For helium, for S block elements we have to take anomalous behavior. Instead of D, we have to take P. Only that much. But you are studying the p block elements, these anomalous behavior is enough. So this is the reasons for anomalous behavior of nitrogen. These are the reasons or the properties which gives anomalous behavior of the nitrogen from the different elements. Okay. So the next one is the compounds of nitrogen. Next one is compounds of nitrogen, that is compounds of nitrogen. Another topic that N2 is there, dinitrogen, and HNO3 is there. NH3 is there, another one is HNO. These compounds we are going to study in the next compounds of nitrogen. Dinitrogen N2, NH3, and as well as HNO. So we will write the preparation students first. How the dinitrogen is prepared. That is sodium nitrate. Sodium nitrate. Nitrite. This one is ammonium chloride. This one is sodium nitrite, ITE. If NO3 is there, that is nitrate or ATE. Okay. Next one is heated. Then it will give N2 nitrogen plus NaCl remains 2 H2. This is the reaction. So this is dinitrogen, sodium chloride, water. How can you say, so students, when the ammonium chloride is heated in presence of sodium nitrate gives nitrogen, dinitrogen along with sodium chloride and also water molecule. So this is the explanation you have to write. So another one is, instead of this, if you take ammonium chlorate, NH4 twice, Cr2O7, ammonium dichromate. K2Cr2O7 means potassium dichromate. Na2Cr2O7, sodium dichromate. NH4 twice Cr2O7, Cr2O7 means dichromate. If it is with sodium, sodium dichromate. Potassium, potassium dichromate. This is ammonium, so ammonium dichromate. Ammonium dichromate. So this ammonium dichromate is heated, means undergoes decomposition. Okay, upon decomposition it gives N2, okay, plus Cr2O3 plus 4H2. So this is chromium oxide. This one is dinitrogen. chromium oxide. This one is, so again we say students, upon ammonium dichromate undergoes decomposition reaction to give dinitrogen, chromium oxide and as well as water molecule. These two are the laboratory method to prepare N2. Understand? So another one method is there by heating or the decomposition of nitrites. Understand? Decomposition of nitrites. Another one, decomposition of nitrites. This is not that much important, but the reaction is there. Okay? So how it is decomposed? So you take barium nitrate as well as sodium nitrate. Na3N. Sodium nitrate are decomposed. So this one is sodium nitrite. So students, if it decomposes, it gives N2 as well as Pa. How many moles of N2 is there? 3 moles of N2. So here, upon decomposition, it gives N2 and Na. Here 3 moles is there, here 2 moles is there. Just cross multiply that, you get the answer. This is the reaction upon decomposition. So this is not that much important, student. This laboratory method is important. Preparation of dihydrogen. One is reaction of NH4Cl with NaNO2. One is decomposition of ammonium dichromate. Okay. So the next one is physical properties of nitrogen. What are these physical properties? Preparation over. And right here. This is not important as I told you. So preparation over. Next one is physical properties. So the physical properties of this nitrogen is, of course, this nitrogen is colorless, odorless, tasteless, non-toxic gas. It is colorless, odorless, of course, tasteless, non-toxic. Non-toxic means non-poisonous. Non-toxic gas. Okay? And next one is it can be liquefied. It can be liquefied. Of course, liquid ammonia is there. You know that it can be liquefied, and it is a non-combustible gas. It is a non-combustible gas. Okay, that means it doesn't support combustion. Either if oxygen is there, it increases the combustion level. If hydrogen is there, of course, it is also increases the combustion level. If this one is there, N2, whether it is presence, absence of N2, neither affect the combustion, not affect anything. Okay. Next one is, so this one is soluble in, spherically soluble in water. Spherically soluble in water. So these are the physical properties. These are not important, student, I am telling you. Of course, they won't ask in the examination, but you have to remember that. If anyone is there, we need to know the preparation, physical property as well as chemical property. So next I will write the chemical property. Okay, in the chemical property, we are going to study reaction with metal, reaction with oxygen, reaction with hydrogen. And just say N2 is there. If it reacts with hydrogen, N2 is there. If it reacts with hydrogen, of course it forms NH3. that is preparation of NaCl later it is there. So students, for this we require iron as catalyst, molybdenum as a catalytic promoter, and also reaction condition is 700 Kelvin temperature and 200 atmospheric pressure. This is the condition. First one, what? Reaction with hydrogen. Second one, reaction with oxygen. As I told you, they form oxidation state in +1, +2, +3, +4, +5, but the most stable is 1. If it reacts with oxygen, then it forms at 2000 Kelvin. 2000 degrees Celsius, then it forms to N. This is how they react with N. But it may form NO2, N2O5, N2O3, NO also, okay, N2O also. That depends on the temperature and the reaction conditions. And the next one is when they react with metals. Here it is in +3 oxidation state, here it is in +1 oxidation state. In this, they are in -3 oxidation state. Forms lithium nitrites, Li3N compounds. This is 6, this is N2, this is 2. Lithium nitrites. Another one is there, magnesium. This will also form Mg3N2. This is 3Mg. So these forms nitrites. These are the chemical properties of nitrogen. So students, these properties you already studied in S block elements in first year. Okay, how they react with nitrogen, how they react with oxygen. Understand? So this is all about preparation, physical property and chemical properties of nitrogen, dinitrogen. So in the tomorrow's class we will discuss about the compounds of dinitrogen. The compounds, their preparation, physical property, chemical property. Everything has their preparation, physical property and chemical property. Understand? And another one, anomalous behavior of this nitrogen is nitrogen doesn't have any allotropic form, but remaining elements, phosphorus, arsenic, all are having allotropic forms. Understand? That is one. Remember, in the next class I will continue with the same topic. Thank you.